Okay, hey everyone, welcome to the IICPC Inter-IIT Competitive Programming Conclave. We are thrilled to have you all here today as we unite allied competitive programmers and developers from over 40 IITs, triple IITs, NITs, BITS, and many other prestigious universities. Our mission is to ignite passion and interest in competitive programming while offering support to beginners and fostering a vibrant community of problem solvers. We are especially excited to announce AlgoZenith as one of our gold sponsors. AlgoZenith stands as one of the India's premier platforms for internships and placement preparation, specifically designed to help students create high-end product-based companies. Their comprehensive preparation programs cover data structures and algorithms, DSA, development, competitive programming, and extend to projects, resume building, and reference, ensuring the best possible outcomes for their students. What makes AlgoZenith even more impressive is their track record. Many of their students, including those from Tier 3 colleges and non-circular departments at IITs have successfully secured positions at top tier companies like Google. This speaks volumes about their commitment to excellence and their effective preparation strategies. We are also honored to have Vivek, one of AlgoZenith's founders and a competitive programming enthusiast at Heart, join us as a mentor. Vivek's guidance and expertise have been instrumental in structuring this camp, and we are grateful for his contribution. He has taken the first session on DP. Now, thank you, AlgoZenith, for your invaluable support. Let's embark on this journey of learning, coding, and excellence together. 0xPPL, our next sponsor. 0xPPL is a crypto slash Web3 company founded by Prasanna Sanskar, who previously founded Rippling.com, now worth 10 billion plus dollars. He has ranked hashtag win in India in top quarter slash ACM ICPC slash Google Code, Jam, etc. When he was 18. 0xPPL has hired several ICPC World finalists and wants to support the next generation. If you are excited about career opportunities in startups, 0xPPL will be a great launchpad. Here's Prasanna talking about why blockchain is the new steam engine. If you're interested in learning more, Prasanna's other talks on how to spot great opportunities in life. You can reach out to Prasanna at the 0xPPL.com to connect. Thank you all and let the conclave begin.
Right. So, hello guys. I hope that you are doing well. Thank you for joining in on a Sunday afternoon, right? You decided to do competitive programming on a Sunday afternoon. That's great. So, today we'll be covering two interesting topics. One of it is BitMasking DP, okay? And the second topic that we'll be covering is Digit DP, okay? At the end of it, I want you all to realize that all of these are just names. And if we more or less have the solution in our mind on how to solve it recursively, can come up with digit DP or bitmasking DP by ourselves. Let's get started with bitmasking DP. Okay. So bitmasking DP or DP with bitmasks, like whatever. Right. And my way of teaching y'all is through problems. So let's look at a problem and see what the solutions can be. I hope everyone is active. You can write something in the chat. That would be great. I know that I'm audible, everything is clear, right? So this is problem O of AdCoder DP contest. For people who don't know what AdCoder DP contest is, it's a great way to learn um, dynamic programming, practice dynamic programming, right? So it's O matching. There are n men and n women, both numbered from 1 to n. Each man and each woman has a number 1, 2, so on and so forth up to n. For each I comma j, the compatibility of man I and woman j is given as aij. If aij is 1, man I and woman j are compatible. If aij is 0, they are not. Taro is trying to make n pairs consisting of a man and woman who are compatible. Here, each man and each woman must belong to exactly one pair. Find the number of ways in which Taro can make n pairs modulo 1 in 9 plus 7. Okay. So what does the problem statement say, guys? Let's take this simple example. There are n men and n women. Each men and each woman has a number 1 to n, like man 1, man 2, man 3, man n. Similarly, women also have numbers 1, 2, 3, 4 up to n. Okay. So if I want to know that something is compatible or not compatible, we can look at this table. Let me just write it down in my tab and then I'll explain it to you. Great. So there are 3 men and there are 3 women. Okay. Each one, like the rows can be considered as men and columns can be considered as the woman. So this is man 1, man 2, man 3. This is woman 1, woman 2, woman 3. You can see that man 1 is compatible with woman 2 and woman 3 and so on and so forth. Now our task is to create a matching. First, we have to count the number of matchings also. But what is a matching? A matching is each man should be paired up. Okay. Each man should be paired up with a unique, compatible, compatible. I'm sorry for messing the spelling up, but woman. Right? This is our task. For example, if we look at one possible matching, let's have a look at that. 1, comma 2, 2, comma 1, 3, comma 3. So let me just write it down. 1, comma 2, 2, comma 1, and 3, comma 3. Okay. So if you look at this, guys, in this particular matching, this is a valid matching. Why is this a valid matching? First, you can see man 1 is paired up with woman 2, man 2 is paired up with woman 1, and man 3 is paired up with woman 3. You can see that man 1 is compatible with woman 2, man 2 is compatible with woman 1, and man 3 is compatible with woman 3. So this is one valid matching. Okay. We want to count. What is the task? We want to count the number of valid matchings. Okay. Number of valid matchings. Before moving on to how we could solve it and how to use DP, I want you all to answer one question. How would we do this the brute force way? How would we do this using brute force? Anyone? Anyone would like to try? How would we do this using brute force, guys? Let's see if someone can come up with this in the chat. Also, last time I was having issues with the chat thing, so this time I put up the chat as a priority so that I can interact with you guys. Try all combinations. Yes, you are right. We can try all combinations. Okay. We can store all valid pairs. Exactly. So what Kaushal says and what many of you say is right. How can we do this using brute force? We can generate all permutations. Okay. Now, what do I mean by I can generate all permutations, right? For example, let's say I have an array. Initially, there are 3 people. So let this be the array. Now we can see the array also has indices. What indices does it have? 0, 1, 2. But let's consider we have one based indexing. We have 1, 2, 3. So guys, if we generate a permutation, okay. For example, this is 1, 2, 3, but let's say 3, comma 2, comma 1. Okay. And this is 1, 2, 3. These are the indices. What we can say is for this permutation, let's match up woman 3 with man 1, woman 2 with man 2, and woman 1 with man 3. We can just check if this is valid or not, right? Now, can someone tell me how many permutations we can have? First of all, is it clear? Like, if we generate a permutation, we can say that whatever is on the first position, that indice woman matches with the first man, then whatever is in the second place matches with the second man, so on and so forth. We check this. And now, if it is valid, we do answer plus plus, right? And we can generate all permutation. Yes. So we can see that there are n factorial permutations, right? And since there are n factorial permutations, and checking each permutation is a big O of n task, right? Because there are n factorial permutations, you generate a particular permutation, then you check if it is valid or not. So we can do n factorial into n operations and get this checked. Another thing to notice here is that my answer can be n factorial. Like if everything is 1, if all matchings are possible, then there are n factorial possible valid matchings. So if we look at the problem statement here, n is smaller than equal to 21. Now guys, 21 factorial is a really large number. You can't store it in long, you can't store it in an integer. Hence, the problem says that we need to print modulo 10 raised to 9 plus 7. Is it clear how do we do it by brute force and why mod was mentioned in this particular question? Tell me guys. Put a yes in the chat if it is clear. Great. Okay. So guys, now we want to come up with a recursive kind of solution for this. Because if we can come up with a recursive solution, we can, Harshit says, please explain again. What do you want me to explain, guys? Just let me know and I'll get that explained. Yeah, what do you want me to explain again? Just one. Just put it up in the chat and maybe I can take it up. Okay. Okay. Fine. Yeah. Great. Okay. I'll just explain it to you guys, right? So guys, I have an array. Okay. It's, let's say, 4 elements. Each has a position, the first position, second position, third position, fourth position, right? Now, let's say that these indices are men. Okay. This is the first man. This is the second man, so on and so forth, right? Now, whatever element is here, whatever element comes over here, I can say that that woman matches with the first man. Similarly, whatever element or number comes in the second position, I can say that that matches with the second man. Yes or no? Is this much clear for people who didn't understand? Yes or no, guys? Tell me. Yes? Okay. Now, this thing has to be unique, right? It has to be a permutation. No number can be repeated once, and all numbers from 1 to n have to be there. Basically, no number from 1 to n can be repeated. Okay. And all have to be taken exactly one time. Okay. Now, how many possible sequences are there? If you look at it, there are n numbers I want to place in n boxes. For the first box, I have n choices. For the second box, I have n minus 1 choices, so on and so forth. In the last box, I will have only one choice. So the number of possible sequences is n into n minus 1 into n minus 2 up to 1, which is nothing but n factorial. So we have n factorial possible combinations. And let's say you generated a possible combination. You also need to check if it is valid or not, right? It is not O of n time complexity. Checking if each sequence is valid for a particular sequence, to check if it is valid or not, I can do it in big O of n, right? For one particular sequence. So how much time are we consuming? We are consuming n factorial into n, because for each, yes, for each sequence, we need to check if it is valid or not. So that is yes. Great. So now, guys, if this much is clear, let's move on to the recursive solution. Now, we let's say we are the people who want to do the matching. Let's say you are a matchmaker. Okay. So we will process in order. Whenever doing dynamic programming, it's important to maintain some order, okay, so that you can do recursion. So what will we focus on? We will iterate from man to man. Let's basically what my idea is, I will first fix a woman for the first man or man one, then I will fix a woman for the second man, so on and so forth. And in the end, I will fix a woman for the nth man. Okay. In the end, if I am able to do that, I will add one in my answer. Okay. And I am going to do this recursively. Make sense, guys? Does this much make sense what my approach is going to be? Tell me, guys. Yes. Okay. So if this much is clear, how do we go about writing this? Right? So one thing to notice is that since we are processing in order, let's say I'm on the third man, right? Do you agree that for the first man and for the second man, I have already fixed some particular woman to match with? Yes or no, guys? Tell me. I have already made some matching. And for the third man, I cannot, okay, I cannot pick those two women. Yes or no? I have already fixed for the first man some particular woman. For the second man, I fixed some particular woman. For the third man, I cannot pick those two women. So an important observation here is that we will require which women have already been taken. Okay. We are going to require which women have already been taken. Okay. This is a thing that we need to maintain. Is this much clear? For writing a recursive solution, if I'm on the ith man, some women have already been taken, so I cannot take those. So it is important to maintain which women have been taken. Great. So if this much is clear, we want to maintain some sort of visited array. If you have done a little bit of graphs, or if you haven't done, what we can do is we can maintain a vector, okay, of size n, where if a woman has been taken, let's say the first woman has been taken, then there will be a 1 in that case. Otherwise, there will be a 0 in that case. Okay. So we can maintain this as a parameter. So what is our basic code? Let's have a look. I'll write it down here only. let's say my function is integer and find pairing. Okay, it's int kerman, and let's say we have a vector called visited. Make sense, guys? I know which current man I am on. Yes, exactly. And we have a visited array. Now, what our basic idea is, if I reach man n plus 1, or let's say I am, if kerman is equal to n plus 1, okay, I'm processing in order. If I have processed all the men and I have reached n plus 1, can I say I can just return one here? Why can I return one here, guys? Because I have reached a valid matching. Yes or no, guys? Tell me. Yes, yes, it is. I'm moving towards that. Just moving towards that, guys. So I am, if I have reached the last man, I processed man 1, man 2, man 3, man, so on and so forth up to man n, I can say that, okay, I've found a valid matching. I will now pass, right? Now, otherwise, I have to, if I have not reached man n, right? So let's say I have an integer called num ways, which will store what are the number of ways, okay, which is initially 0. And here I will return it. Return num ways, right? This is a particular variable that I'm going to have. Now, what is our task? We have some woman, okay, here in our visited array, we are going to have some women who have not been matched yet. So what are we going to do in this particular case? We are going to iterate through all women who have not been taken. For example, we'll iterate to woman 1, woman 2, woman 3, woman 4, and up to woman n. We'll check if this particular woman has been taken or not. If this woman has not been taken, we will check, is this man compatible with that particular woman? Okay. And if they are, then I can go to current man plus 1, and I, in that visited array, I can mark that that woman has been taken. Is this idea clear, guys? I will write it down on the tab in just a minute, but is the idea clear? What does this block of code, this block right here, have to do? We'll iterate over all women. We'll check, has the woman been already paired or not? And if this woman has been not paired, we will check, is it compatible with the current one? Okay. So in the block of code, what are we going to do? I will iterate from I is equal to 1 to I is equal to n, right? Yes, yes. You can't take it, but yes. I will iterate from 1 to n. Basically, I'm iterating to check if woman, if that particular woman can be matched, right? So here I'm going to check what? If visited of I is equal to 0. If visited of I is equal to 0, it means that this woman hasn't been taken yet. Okay. And apart from this, is compatible. I in my input I have been given this matrix, right? So is compatible current man, okay, current man and I. Okay. So if this is the case, what am I going to do? I am going to mark visited of I is equal to 1. Then for this function, which is find pairing, okay, I'm just calling it f for now. I'm going to call f of current man plus 1, because currently I have matched this man with this particular woman. So I'm going to the next one and visited arrays as it is. Then after exploring that, I'll just mark visited I as 0. if you have done a lot of exactly, it's just backtracking, right? Backtracking, recursion, whatever you say. So if you have done recursion or backtracking problems, this idea should be very intuitive or very common to you all. So is this idea clear, guys? What are we going to do? This is the block. Okay, just recapping. If I reach the man after the last man, basically n plus one man, I can return one. Otherwise, I have to count ways. Okay, I have to do num ways plus equal to, sorry for that, num ways plus equal to this, right? And so on. Harshit says you must also need an array where you are storing the man-woman pairing or not. It doesn't really matter. If I am on a particular man, I only need to know which woman have not been taken yet. Like, does it really matter that, for example, um, let's say, let's take a common example, right? You are in a classroom and you are searching for an empty chair. Does it matter who is seated on which chair? It only you only need to check which chairs are empty, right? So we only need the visited array to check which women have not been paired yet, and we need this to check where it is uh, compatible. Okay. So now, if this much is clear, guys, congratulations, you have already learned DP with bit masking. Okay. Now you might be telling me that Gaurish, there is no bit masking here. Actually, what are we actually doing? So let's have a look that Pranav says why visited I again is equal to 0, because we are iterating through all possible pairings that I can make. So let's say I matched with woman 1 first. Okay. So I marked it as 1. But when I'm matching with woman 2, that time visited of 1 should be 0, right? So first I mark it as 1, then I go in that particular loop, and then I mark it as 0. Can't we use use integers representing AI? That would be easy for us. Not okay. So is this much clear, guys? Put a yes in the chat if this much is clear. Then I'll move on to how does this work with DP with BitMasking. Okay. Just put a yes in the chat if it's clear. If it's not clear, do let me know. Okay. Ankita says, what is num plus equal to function for? Here I'm counting num ways, right? So this is actually num ways. So I need to return the number of ways. So this function will return this. This is basically find pairing. I've just written it as F for now, but it's find pairing. Okay. Great. Yes. So guys, now how do you convert this to bitmask, and why is it called bitmasking DP? Now we can see that we have a visited array, okay, which is going to be 0 or 1. Each element here is going to be either 0 or either 1, right? Now, this storing this is going to take a lot of space, and memoizing a vector. You can do that. You can memorize a vector, but it doesn't make sense. So we need something much more efficient to memorize this. So instead of having a visited array, we can have an integer, because this thing can be stored as a binary number. Yes or no, guys? Like, let's say there are 4 women. So initially I can store it as 0000, which in integer is 0, right? And similarly, let's say the first woman has been taken. So that can be stored as 0001, because this is 2 raised to 0 and so on and so forth. And in integer, it can be written as 1. So instead of storing this as a vector, we can store it as an integer, where This is the 2 raised to 0 place, 2 raised to 1 place, 2 raised to 2 place, 2 raised to 3 place. This represents if the first woman has been taken or not. This represents if the second woman has been taken or not. This represents if the third woman has been taken or not. And this represents if the fourth woman has been taken or not. Yes, right? So now we found out that instead of using a visited array, we can use an integer. Now there is one more small optimization that I want you all to consider, and it's very beautiful. Like it's a very common observation, but let's see if you guys can observe it. Guys, let's say I'm on the third man, okay, and I want to pair this, right? I want to make this pairing. So my visited array is going to be, let's say, 0, 1, 1, 0. Okay. So you can see that two women have been taken. And in binary, let's say 0, 1, 1, 0. Okay. Same thing. Now, tell me, guys, do I really need to know this number? Like, if I only store this visited array, can I come up with this number by myself? Tell me. By only looking at that visited array, can I know which man I am pairing right now? Anyone would like to try? It's a beautiful observation. Like it's not that hard, but yeah, how can we do this, guys? Tell me. Exactly. Excellent, guys. So if I want to know which man I am on, I can just look at the visited array. Here you can see that there are two bits which are set. Okay. So the man I am on right now is 2 plus 1, which is 3. Why does this work? Because let's say if I am on the ith man, okay, there will be I minus 1 woman who have been paired, who have been already paired. So I just need to know how many women have been already paired and I can know which man I am on. Now, if we are talking in one based indexing, it's number of set bits plus one. But if you want to work in zero based indexing, this is one based indexing. Now, if you want to work in zero based indexing, it will just be the number of set bits. Yes or no, guys? Tell me. Yes. Great. So now to count the number of set bits, I hope you know this. But if you don't know this, there is already an inbuilt function called underscore built in pop count. Okay. Let me just show the code to you. Like this underscore built in pop count. And if you put the mask, you'll get the number of set bits. So if this much is clear, our dynamic programming solution is now more or less done. How is it done, guys? What we can do is we can just store the mask. Okay. This stores which women have been taken yet. Now I want to store which man I am on. So let's say I want to know which man I'm on. So index is just number of set bits of this mask. Okay. And in the end, I am just going to do what I discussed over here. If my man is n plus 1, I'm going to return 1. Otherwise, I'm going to have a number of ways, integer, and I'm going to iterate through this and so on and so forth. Is DP with bit masking clear to you guys? Tell me, guys, do you now understand DP with bit masking? Is it as hard as it used to be? Tell me, guys. It seems like an advanced concept, but is it any advanced anymore? Let me show you the code as well. But before moving on to the code, to know if the idea is great. So let's look at the code. Okay. So if we want to look at the code, it's just int n c in n. And now this is, let me just use this as input, right? So since we would be needing to store this matrix, this is a matrix, and then we need to store the bit mask as well. Okay. Now, there are how many possible combinations of the bit mask? There are 2 raised to n possible combinations of the bit mask, right? So there are n positions, and each one can be either 0 or 1. So how many total combination masks can be there? That can be 2 raised to n masks. So that's why in the DP, I have set this as 2 raised to 1, and initially it's -1. Okay. So here I am taking an input, and here is my DP function. Okay. Now, if mask is equal to 2 raised to n minus 1, or I can say that, let me just write this over here. Okay. If index is equal to n, it's the same thing. Since I have mentioned this, I'll be using this. If index is equal to n, I'll be returning 1. Keep in mind that I'm using 0-based indexing and not 1-based indexing, right? If I was using 1-based indexing, this would have been n plus 1. But since I'm using 0-based indexing, I'm using n. Okay. Now, if dp of mask not equal to -1, basically if it has already been memoized, then I am returning this. Otherwise, what I'm doing is I'm going through all women, right? Now, if that woman has not been set, how do you check if a woman has not been set? I want to check if the ith bit is unset. So if the mask bitwise ended with one left shift I, if it gives 0, it means that uh, okay, great. So if the ith bit is set or not, this is what I want to check. So if mask and 2 raised to I is unset, then I can say that, okay, it is unset. And then we also need to check if the pairing is valid or not. It's a good pairing. So I check that using this. This is 0 or 1. So I can just put this is equal to 1. So in that case, I just do answer is equal to answer plus f of mask. You can do plus here, you can do or here, but basically in the mask, we just need to set that particular woman as taken. So that is why I just put an or here. You can see that I don't need to do the setting and unsetting here because I am not changing the mask. Like I am not doing any operation in the mask. If we look at the code here that I shared earlier, here we were using a visited array. So the visited array changes here. So that is why we needed to change it. But in this particular case, we do not need to change anything because mask remains changed, and you can see that this is more or less DP with bit masking for you guys. Nothing really that complicated, and I hope you guys understand the time complexity of this. As you can see, let's have a look at the time complexity analysis. This mask, how many unique possible combinations can it have? It can have 2 raised to n unique combinations. So this function will be run at most 2 raised to n times. And since it is run 2 raised to n times, you can see that this function itself runs for O of n because there is a for loop that runs from 0 to n minus 1. So the time complexity here changes from uh, it becomes big O of 2 raised to n into n, right? It's big O of 2 raised to n into n. And since n is 21, 2 raised to 21 into 21 is not such a big number. What difference will it make from the previous solution? The previous solution wasn't memoized, Ramesh. So it becomes a lot. Like you can use Master's theorem and analyze that. Yeah, exactly. That is like n factorial. Exactly. Great. So I can share this. Like moderators can share it in the chat. But I hope you guys now understand what DP with bit masking is. Yeah, if constraints is greater than 64, you can't really. Uh, so Suraj asks, what if n was 64? In that case, you can't really use DP with bit masking because you can see that we are iterating over um, bits, right? So this bit mask is 2 raised to n. So 2 raised to 64 is like 10 raised to 18. So this bit masking solution kind of only works when there are like 20, 22 kind of uh, numbers to deal with. I hope I could answer your question. Uh, if you can, Dhruvin asks 2 into 10 raised to 6 is working in 1 second. It is less than 1 second. If you want to know, um, okay, IITN aspirant asks, why is it 2 raised to n? Because very simple. Okay, we are memoizing this. Okay, what does it mean by memoizing? We are storing the answer for each mask. So, do you guys agree that each mask will come across each mask only once, not more than once, exactly one time? Now, how many masks are there? There are 2 raised to n masks, right? So that is why the 2 raised to n comes in our time complexity. And for each mask, we are doing an O of n operation using this for loop. So 2 raised to n into n. Please explain the for loop part again. It's very simple. How to recognize it? It's a DP with bit masking question. Solve some problems. I'll be sharing some DP with bit masking problems, and you can solve it. And once you get an idea that you can do it, you can understand that you can use DP with bit masking. Another basic kind of advice for you guys in competitive programming in general is that don't try to fit algorithms in problems. Rather, try to solve the problems and then discover that you can use some algorithm as a tool to solve it, right? Uh, think about it in this way. You are in a war. So, depending upon what the situation of war is, you decide what gun to pull out or what to pull out, right? Like if you're close range, you pick up a knife, and if you're long distance, you pick up a sniper. So don't try to fit things in it. Just look at the situation and try to understand. Okay. So that is more or less it for DP with bit masking. Yes. Can you explain the if condition for the for loop? Yeah, sure. So I am matching. Let me just quickly take this up. So let's say I'm matching the ith man, right? So there, I'm iterating through woman to match. Now there are two conditions I need to check. That first, this woman hasn't already been matched. Okay, already been matched, right? And the second thing that you want to check is this man and this woman compatible? Okay, so if you want to check that, how do you do that? Let's have a look at the code. This part of the code is basically to check if the woman has not been taken, right? Because if you look at the bit mask, the position at 2 raised to I should be 0. Now, how do you check if something is 0 or not? Let's say the bit mask is 0, 1, 0, 0. And you want to check, has the second woman been taken or not? So I will just keep this bit mask, which is 2 raised to I, which is 2 raised to 1, because I want to check the second woman. And when I bitwise and this, if this woman had already been taken, it would return me 2 raised to I. But if since this is 0, it would return me 0, 0, 0, 0. So since this is 0, I can say that this woman has not been taken. So yeah, this checks if it has not been taken, and I'm just checking that uh, it's a valid matching. So that is all that I need to check. I hope this much is clear, guys. For the person who was asking the doubt, is the part clear? Great. I will surely share the submission link. I'll share it to you guys. Okay. Just share it in the chat after some while. I'm okay. Great. It'll be 0 because we have not paired any woman yet. So that is why we would be calling f of 0. That is something that I forget to mention. So thanks a lot for mentioning. You'll be calling f of 0 because initially the visited array is empty. Great. So that is DP with bitmasking for you guys. Now let's move on to the next topic, which is digit DP. This is another topic which is looked up as a scary kind of topic, and we'll be decoding that today. Yes, I'll share it post lecture. Okay. So, what is digit DP, guys, and where will you find digit DP problem? A basic template you can keep in mind, like it's not necessary, but usually when digit DP problems come up, it is like you for a given n, okay, where n is smaller than equal to 10 raised to 100 or 10 raised to 1e5 or so on and so forth. You need to count the number of numbers, uh, with a specific property, with a specific property where those numbers are smaller than equal to n. Okay. The second kind of question that you might come across is you are given L to R, where both L to R are smaller than equal to 10 raised to 10 raised to 5. Okay, this is a very number. It's a number with 10 raised to 5 digits. You can't store it in an integer and you can't iterate over it. And similarly, you need to count the number of numbers in this particular range with a particular property. So let's have a look at a digit DP question. Okay. So this is the most basic kind of digit DP question for y'all. Find the number of integers between 1 and k satisfying the following condition. That is, the sum of digits of that number should be a multiple of d. We are given k. You can see that k is smaller than equal to 10 raised to 1e5. And d here is smaller than equal to 100. So we need to count the numbers which are a multiple, like the sum of the digits are multiple of d. So you can see that this is 30. So all numbers smaller than equal to 30 we have to count. Is the problem statement clear, guys? Tell me. Like here you can see that there are 4 integers, 4, 8, 13, 17, 22, and 26. Why is this the case? Because 2 plus 2 is 4, which is divisible by 4. 2 plus 6 is 8, which is divisible by 4. 1 plus 7 is 8, divisible by 4. So the answer in this case is 6. Okay, right. So what does the problem statement say, guys? You are given k and you are given d. You need to find the numbers which are smaller than equal to k, and sum of digits of that particular number is divisible by t. Okay. So what is the most basic brute force approach in your mind, guys? Tell me. How will you solve this using brute force? Tell me. Let's have a look if someone can come up with the brute force solution. But it's very simple. Don't need to think much. Brute force solution. Exactly. As Chinmay says, what we can do is we can just run a for loop from 1 to k, right? And we can check if, let's say, we have a OK function. So if OK of I, then answer plus plus. Okay. And in the end, we'll print out answer. Make sense? Great. Now, if this makes sense, we need to, we can't really use this. Okay. I hope this is clear. We can't really use this. We'll be using this idea only, but we can't really use this because this is O of K into whatever your check function uses, right? So even if this was O of 1, it would take us O of K, and O of K is 10 raised to 10 raised to 5. So this code is going to compile after the universe ends, right? It's a lot of time. So it we can't really use this. So we need to use a smarter way. Okay. And how do we do this using a smarter way? Let's have a look. So our goal here is, guys, we have to use recursion in a smart way to tackle this. How do we use recursion in a smart way? The thing is, let's generate numbers. Okay. Let's generate numbers, right? Let's say what is the number 30. Okay. I'm not going to take 30. Let's say I want to generate numbers smaller than equal to 12 using recursion. How do I do this? And that too, I want to do it digit by digit, right? So let's say we are fixing the most significant digit first. Do you guys agree that the first number can only take in either a 0 or a 1? It cannot take a 2 because let's say I took a 2, then 2 0, it is already bigger than 12. So if I want to generate the numbers that are smaller than 12 for the first or the largest number, I can take either 0 or I can take 1. Yes or no, guys? Tell me, guys, like we want to generate the number. So we are iterating over digit by digit and we are fixing numbers. So let's say I'm in the most significant position. I fix 0 and 1. Okay. Now, guys, a very important question to ask. Here, in this particular case, where I have taken 1, now here I have only three options. I can either make it 1 0, or I can make it 1 1, or I can make it 1 2. But in this case, I can make it 0 0, I can make it 0 1, I can make it 0 2, and I can do so up to 0 and 9. Yes or no, guys? Tell me. Yes? No? Yes. Now let me take one more example to make this much more clear, right? Um, let's take 22. So here, for the first digit, okay, I can either take a 0, or I can take a 1, or I can take a 2. Now for 0, again, I can take all numbers between 0 to 9. For these numbers, for 1, I can also take numbers 0 to 9. But for 2, guys, I can only take the number between 0 to 2. So what is the basic observation here? Tell me, guys. Like, anyone? Like, even if it was 2 to 3, after this, I am free to take any numbers between 0 to 9. But let's say there will be a case where I took 2, then here I can again take only 0 to 3. For 2, why only 0 to 2? Shivesh, because the numbers uh, we can generate is 20, 21, and 22. If I take 23, it becomes larger than 22, right? So it's not allowed. Okay. Is that much clear, Shivesh? Okay. So what is the basic observation, guys? That one, let's say the number is 2 to 3. Okay. Till now, let's say you have fixed some number. Let's say you have fixed 22. Let's say this is 2 to 22359. Okay. The numbers I have fixed is 22. This 22 exactly matches with this 22, right? So in this particular case, I am forced to take between 0 and 3. But for example, if it was 21, now you can see that this number does not match with the starting two numbers. So in this case, I'm free to take any numbers between 0 to 9 because this will never exceed this particular number. Yes or no, guys? Tell me. For the next digit, for 22, I'm forced to take between 0 and 3 because this number is bounded. But let's say I've already taken somewhere a number which is smaller than the prefix. Then for next any number of turns, even if I take 21999, yeah, this will still be smaller than this particular number. Does it make sense, guys? Okay. Okay. So, um, yes, prefix is equal to any of the otherwise yes. Okay. So let's have a variable in digit DP. Usually there is a convention that we are going to have a variable called is tight. Okay. Each type determines that whether we are going to iterate from 0 to the digit of whatever digit we are on, or we are going to iterate from 0 to 9. Okay, this is what each type is going to determine. So each type, if it is 0, it means that our current recursion is not tight. I'll explain what this means. And then we can iterate from 0 to 9. Otherwise, if it is 1, we have to iterate from 0 to 9. Make sense? Now, how does this each type come into play? Let's say it's 223, right? If the first digit I fixed is 2, each type is still going to be 1. Initially, I have not fixed anything, it's going to be 1. Now, I have fixed 2, so it's already tight. And if I fix 2 again, it's still going to be tight. But let's say I made it 2, 1. So in that case, each type is going to be 0. And for any other case, I am free to select numbers between 0 to 9 for any further case. Does this make sense, guys? Like if it is already 1 and I am fixing that digit, then it is still going to be 1. But let's say if it is 0 or if I have fixed some other number which is smaller than the current digit, then it remains 0 for the next of the recursion. Yes, guys, no, guys. This one's like ranking in dictionary questions, if you really think. Maybe. Not quite sure what that problem is. Hopes. So put a yes in the chat if this is clear, guys. Can we do permutations of number and we are technically IIT and experience, we are technically generating the numbers, but in a smarter. So guys, uh, similarly, how do we write our function right now? Right? First of all, you can see that the numbers can be really large. This cannot be stored, like maybe this can be stored. I've not counted the number of numbers, but this can be stored in a string. Okay. So instead of storing this number in an integer, which is not possible, there are 10 raised to 5 digits. You can't do it. So we will need to store this is an integer, right? So let's say there is 5, 6, 7, 8, 9, 9, 1, 2, 3. Okay. Can we just store this in an integer, guys? Put a yes in the chat if you guys agree, like we can store this in an integer, right? Now, since we are fixing this digit by digit, okay, can I say that I am just iterating over indices of this string? Yes or no, guys? This is the zeroth place, this is the one place, this is the 2, 3, 4, 5, 6, 7, 8th place. Yes. Okay. So what my function is essentially going to do is that I have a function. Okay. Now here I'm going to have the index basically stating that which index I am upon, which digit I am upon. Okay. I am on the 0 digit, first digit, second digit, so on and so forth. Apart from this, I am going to store, I want to store, what does the condition ask me? The sum of the digits in base 10 should be a multiple of D. So basically, if I choose 1, 2, 3, 4, and D is, let's say, 9. So this I want to store 1 plus 2 plus 3 plus 4 modulo 9. So for whatever digits I have fixed till now, I can write, I can store it in a variable called current mod. Yes or no, guys? Tell me. Yes, no. Put a yes in the chat if it is clear. Let me just wait for some time. Okay. So, and here I will have a variable called each type, because as we discussed, if each type is 0, then I can iterate from 0 to 9. Otherwise, if it is 1, I'll iterate from 0 to whatever this s of index is. Make sense? Okay. Chinmay says, can you repeat the f function? Basically, I want to generate the numbers, right? So for generating the numbers, as we discussed, we are going from digit to digit, starting from the most significant digit. So we will need a variable called index since we are iterating through the indices. Now, apart from that, I also want to store what is the mod of the numbers that I have fixed. Let's say it's 20, the number was 22. So I fixed, I can either fix 0 and 1. I can either fix, after that, I can store 0, 1 or 0, 2. But I also want to store what is its mod modulo D, right? So let's say I fixed 0, 1 till now. So let's say D is, let's say 8. So your modulo, the modulo of these numbers, like some of these numbers modulo D is going to be 1. Here it's going to be 2 and so on and so forth. So that is why I'm storing a current mod variable. And then of course, as we discussed, we are going to have the each type variable, which decides that for this current digit, am I going to iterate from 0 to 9 or from 0 to the index? Now, is this much clear, guys? Tell me. Yes. For every number that we update, we need to store what is the current mod of the sum of digits. We are iterating through the digits and fixing them, right? So we can store the mod as and when we are fixing the digits. Yes or no, guys? Tell me. Let me just erase this. I'm having some issues. Okay. Make sense? Okay. Does it make sense for everyone? Tell me. We are having a recursive function and we'll be iterating. Great. So the base cases, we have fixed all numbers till now. So if index is equal to uh, s dot size, okay, it means that we have fixed all numbers till now. Can you guys tell me which number will I be, when will I be returning 1 and when will I be returning 0? This is a task for you guys. Avtan says DP seems easy for now. Thanks for saying that. I hope I'm able to make it easy for you all because it's not that hard. Right? So if index is equal to s dot size, exactly as Ajoy said, no, not D, it will be 0 because we are using modular arithmetic, right? I think this is where people had doubts. Guys, so in modular arithmetic, we have this formula that A plus B mod C is same as A modulo C plus B modulo C, the whole modulo C. Okay, this is a formula. If you didn't know this, maybe you guys had doubt there, but we can store this ad hoc, right? So if I know A modulo C, then if I want to store A plus B modulo C, I can just do A modulo C plus B modulo C, and then I can take the whole modulo C. And then if there are more numbers, I can do that. Okay, so I'll return one. So if cur mod is equal to 0, I will return 1. Otherwise, I will return 0. Okay, yeah, you can do that as well. You can return not current mod. So if current mod is 0, you return 1. Otherwise, you return 0. Okay, now you have two conditions for you, right? If current height is 1, okay, if cur height, there are two conditions. Each will have a separate code. You can do that in one code as well. So if current height, if each type is 0 and if each type is 1. Now, if each type is 0, what are we going to do? We are going to iterate from number 0 to 9. And then for our particular answer, we are of course going to have a num base variable. Okay. And then we are going to iterate through these numbers. And we are just going to do num base plus equal to, we will be calling index plus 1, index plus 1. We will be updating the current mod, right? Because the current, since I am taking, let's say, digit I, so my mod will be whatever the current mod is plus I modulo 1 modulo D. And here I will be passing 0 because since each type was already 0, it is going to remain 0. Is this much clear, guys? If each type is 0, we'll be iterating through digits 0 to 9 and we'll be fixing the digit in that particular place. Let's say it's 1, 1, and we need to fix this. So we'll say what happens when this is 0, what happens is 1, and so on and so forth, up to what happens when this is 9. Is this much clear for you guys? Like, I'm not able to see the chat. Load that again. Something up. No. Great. Praveen says it is clear. What about others, guys? Put a yes in the chat if it is clear. It will help me understand if things are clear for you guys. Okay. Okay. Let me explain it slowly. Okay. Okay. So, guys, what is each type? As we discussed, each type will be 1 if the current prefix is matched as it is. Otherwise, it will be 0. So if you want to fix a current digit, let's say n is 225, and you have fixed 22 and you want to fix this, in this case, each type is going to be 1 because the prefix of this number is same. So in this case, you are bound to choose the numbers between 0 to 5. Yes or no? Is this much clear? Is each type clear? Yes. Yes or no, guys? Is this much clear? Okay. Now, but let's say for 2 to 5, you have fixed 21. So in this case, you can, if you want to fix this number, it can be anything between 0 and 9. So that is why each type is going to be 0 and each type is going to be 1. This much is clear, guys. Tell me. Okay. Now, if this all of this is clear, okay. Let's say let me give you an example. Let's say B is 4, okay. And I want to know that, let's say 2 to 4. In this case, if you take the sum of the numbers, which is 2 plus 2 plus 4, and you take it modulo 4, it will be 0. But let's say I am fixing this number by number, okay? The sum of the digits right now is 2 plus 2, which is 4. And if you take it modulo 4, it is 0. Now I have some choices. I can either pick 0, 1, 2, 3, or 4. If I choose 2 to 4 here, how does this mod change? It becomes 0 plus 4 and modulo d, okay, which is basically 0. So does it make sense that in my function, I'm going to keep a current mod value which stores whatever digits I have stored, the sum of that modulo d. That is what current mod is going to store. Is this much clear, guys? Tell me. David says, why is your iPad time and day wrong? It's not wrong. Whenever you cast your iPad, it goes to 9:41 a.m. Jan 9. And I think that is the time when the first iPhone was launched. So that is why just Easter egg. Initial current mod will be 0, Ramesh. Okay. Initially, we have not decided any number. So current mod is going to be 0. And then let's say we have not fixed anything, right? So let's say D is 4. Let me give a quick example because I think it'll help you guys understand. That is something that I'm not doing. So initially current mod is 0. Let's say I fixed 1 and D is 4. Okay. Or let's say I fixed 9. So it will be 9 and I need to fix 2 digits. The current mod is 9 modulo 4, which is 1. Okay. Now let's say I fixed 1. Okay. So it becomes 91 and this. So the current mod is 1 plus 1 modulo 4, which is 2. Okay. And now after this, if you look at I fix 9, 1, 2. So this becomes 2 plus 2 modulo 4, which is 0. And as you can see, 9 plus 1 plus 2 is 12 and 12 modulo 4 is 0. So if I store it in a running fashion like this, right, mod 2, I am able to achieve the same thing as doing it in the end. Does it make sense, guys? Now what current mod is and what current mod is actually doing? Like if we fix a number, then while we are fixing the next number, if you want to update what current mod is, then current mod will be 2 plus whatever number we fixed modulo d. Yes, guys, does it make sense? Okay. So if these things are clear, let's move back to the function here. Okay. Let me just erase all of this. Okay. So getting back to the function, we are going to have 3 variables: index, current mod, and each type. Index is which digit we are fixing. Current mod is the current mod that for the number that we have fixed, what is the current mod, and each type is basically for the current index, can I take the number 0 to 9 or can I take the number 0 to s of index? Now, is it clear, guys, that now we will fall for 2 conditions. If each type is 1 and if each type is 0. If each type is 1, I'll be iterating through numbers 0 to whatever s of index is and fixing them in the current place. Otherwise, I will be fixing numbers from 0 to 9. Is this much clear for everyone, guys? Tell me. You saw that this is our base case. And now, if each type is 1, I can, for the current digit, I can fix numbers from 0 to s index. Otherwise, if each type is 0, then I can fix number 0 to 9. So you just have a num base variable and you just iterate from 0 to s index and you add it to your answer. And similarly, if each type is 0, you can iterate through the number 0 to 9 and add it to your answer. And in the end, you will return num base. Okay. Now, how this works, we'll look through the code only. So yes, yes. So it will be running number of indices into D. The number of indices are 10 raised to 5 and D is 100. So the time complexity of that becomes less than 10 raised to 7, 10 raised to 8, which works, right? We are going to take index from 1, considering operation at index 0, which we'll do outside. No, we can start from index 0 as well. Each type initially is 1. Like when I have not set anything, when I am setting the first number, okay, for example, 1, 2, 3, 4. When I'm setting the first number, each type is going to be 1 because no matter what I do, I cannot put a 2 here or I cannot put a 3 here. So in that particular case, I can only take 0 to 1. So initially, when we are calling the function, we'll call each type as 1. Does it make sense, guys? Ramesh, does it make sense? For the first number, it's always going to be typed. You can't take 9, you can't take 2. You can only take the numbers from 0 to 1. Okay. So if we memorize this, the time complexity of this is number of states into whatever. For each, I'll get back to your question, but if you want to look at the code, let's have a look at it, right? We have a DP, and what are the states? We are going to have index, we are going to have current mod, and we are going to have each type. Okay, each type takes the value between 0 to 1. Current mod takes the values from 0 to mod minus 1, and index is between 0 to string size. So what are the number of states? It's the number of indices, okay, into the total number of possible of mod into 2, right? You can see that the number of indices can be 10 raised to 5. So this is 10 raised to 5 into what is the maximum value of mod? It is 100. So in this particular case, you put 100 and now it's 2. So this is 2e7, which is less than equal to 10 raised to 8. So it passes within 1 second. Okay. Now, if index is equal to h dot size, this is just a cheap way of, not a cheap way, a clean way or an easy way of writing the if statement, right? So if current mod is 0, this returns 1, otherwise it returns 0. I can just write it in a if statement for y'all. Okay, so let me just do that. If cur mod is equal to 0, return 1, otherwise return 0. Okay, this is what our base case is. This is the memoization case. And here we are going to do our answer. Okay, now there are two cases. If it is each type, then I am going to iterate through only the numbers from 0 to s of index. Otherwise, I'm going to iterate through 9. This I'm doing using a for loop. Okay. Now, here, maximum value of mod is 1e9 plus 6. Look, that mod is different. This D, okay, is up to 100. And our mod, which is the mod of the answer, is 10 raised to 9 plus 7. This has nothing to do with the problem. Like this is only there because the answer can be very large. So that is why you need to print it modulo 1e9 plus 7 so the judge can check if it's right or wrong, right? Otherwise in C++, how do you actually print such large numbers? That makes sense. Okay, so that capital mod is different. This small mod is different. Okay, don't confuse both of the mods. This mod is what we have to print, which is modulo, right? So if index current mod is tight is not equal to -1, it means that it is set. Then you can return this. Otherwise, I have an answer. I iterate through all the digits. So digit starts from 0. It is smaller than equal to whatever the constraint is. And you do digit plus plus. Now, whatever I do, I want to add it to my answer. So answer is equal to answer plus f of index plus 1. How does the current mod change? You are fixing some particular digit. So the current mod increases by that digit and you're taking the whole modulo mod. And now you want to check if ishtite will be 1 or 0. So now ishtite will only remain 1 if it was already 1 and the current digit you fixed is equal to s of index, right? If it is already 1 and the current digit you fixed is equal to that digit, then for the next one, ishtite is equal to be 1. So that is all that I'm checking. Is ishtite already 1 and is the digit that you are fixing equal to the index of the digit? Is this much clear, guys? And the whole modulo mod, because we want to print the answer modulo mod and then we are just returning dp of index current mod ishtite. Now, is this much clear, guys? Tell me. Put a yes in the chat if it is clear. No, I will get to this part. Okay, ignore this. I will get here. Is this much clear? Tell me this. Okay, great. Now, if this much is clear, you might be wondering, okay, I am on my 0th index. My current mod is 0 and each type is 1. Why is this -1 here? Okay, so a very simple thing is that the question asks that we need to print between 1 to k. But our code, there is a case in our code where it only takes zeros, okay, which is the number 0. And this number 0 is always divisible by d. So our dp function is going to calculate one extra value. So that is why we need to do a -1. And a minus b modulo mod can be written as a modulo mod minus b modulo mod plus mod, the whole modulo mod. This is a formula for modular subtraction. So that is why I get the answer. I'm subtracting 1 from it. I'm adding mod and then I remove mod from it. Number of operations is 10 raised to 5. Yeah. So 2 into 10 raised to 8. Sorry for that. This is also going to be 10. So it is around 10 raised to 8. So it works. Yes, you are right. I'm sorry for that. I forgot about the for loop. So the time complexity is 10 raised to 5 into 100 into 2 into 10 again, which is 2e8, and it fits within the constraints, like 1 or 2 seconds, whatever it is, 2 seconds. So it passes because it's there. Okay. But negative numbers output negative mod values. Pratyaksh, I would suggest you look at modular subtraction because in no matter what you do, okay, in modular arithmetic, your number has to be between 0 to m-1. It cannot be negative. It cannot be more than m. You cannot really do that. Suraj says, explain why ishtite is initially 1. Let's say the number is 2, 3, 5. You want to set the first digit, right? When you're setting the first digit, you can only set it to 0, 1, and 2. You cannot really set it to a 3 because it will be 3, whatever, 0, 0, it is still larger than this number. So that is why the number, it's initially ishtite because you can only take the numbers between 0 to 2. Suraj, does it make sense now? That is why ishtite is initially 1. Great. So, guys, do you guys understand what you guys have learned? You have just learned digit DP. Not a lot of people in India know about digit DP, and now you guys understand what digit DP is. Okay. Now we covered the first question. Okay. That in 1 to n, you need to count something that you can do it. But what about the second question, guys? Yes, if we are given between L to R and we need to count something, how do we do it? I'll see in the chat if some people are able to come up with it. Like this thing is not hard. This thing is not hard to do. If you know how to do it for 1 to N, you can do it for L to R. So guys, let me give you a very simple solution. You guys know about prefix sums, right? In prefix sum, if you want to find the sum of array from L to R, you do what is the sum of array from 0 to R minus what is the sum of array from 0 to L minus 1. Okay. So basically, you call DP two times. You make either you can make a function and then that does DP in itself. Basically, if you find the answer from 1 to R and you need and you find the answer from 1 to L minus 1, let's say this is X and this is Y, you can just print X minus Y plus mod modulo mod. Yes or no, guys? Tell me. If I find the answer from 1 to R, if I find the answer from 1 to L minus 1, exactly, I can just print, if this was X, this is Y, I can just print X minus Y plus M modulo M. The same idea as prefix sum. So this was digit. Yes, it is just the same thing. So this is the beautiful thing about competitive programming, right? If you truly understand how something works, then it's just a name. Like digit DP is no longer that scary, intimidating algorithm. It's just a way to solve a problem. Similarly for BitMasking DP. And you guys learned it in 1.5 hours. So congratulations on doing that. So yeah, like today we learned about digit DP. Today we learned about bit masking DP. Why the plus M inside? You can have a look at modular subtraction, right? This is, I hope you guys know modular subtraction, modular addition, modular division before coming here, right? So people are asking me lead code or Codeforces. Guys, I'm the kind of person who doesn't like to get into any controversy, so I'll keep my mouth shut. Right. Can you get one more lecture on these two important topics? I will share practice problems with you all. I will make sure that I'm sharing practice problems on the website or wherever it is shared. So the idea is now you know the basic idea of digit DP and bit masking DP. So you can solve problems, right? The problems will be shared. Just practice them. If you have any doubt, you can reach out to us on the Discord group. We'll feel free to resolve doubts for you, right? If you have any. And if there are too many doubts in problems, we can maybe have one session from me where I'll explain solution to those problems. Works? Like I want you all to first try it on yourself, and then we can do that. Yes, yes, I'll share submission of both problems. Don't worry. It'll either be in the description of this video and it'll be shared on Discord and all of those platforms. Hints on solution generation from the LIS lecture. Uh, if you know how to do it for LCS, okay, you can do something similar for LIS. The basic idea is that um, you generate the DP table for LIS. This can be done in O of n square. And once you have the table, you just find a way to traverse through it to find your LIS. Okay. LCS from previous lecture not working for some test cases. I'm not sure why that does not work. Should work. Like that. Okay. So I guess we'll end it here. I don't want to take much of your time. It's Sunday. It's Sunday afternoon. You can enjoy with your family and practice more problems. So that was more or less it for today. So we learned about digit DP, we learned BitMasking DP. I'll be sharing some solutions. It is taking 220 ms for more than 2 seconds. This works. This right here, if you're mentioning this is not working for you, the LCS yesterday. Uh, do one thing, just share your solution over Discord or somewhere. We'll look into it. Yeah, and of course there is the infamous cricket match as well. Yeah. So enjoy your Sunday. Thanks a lot for joining in. Let's end the live stream now. So Dhruvil or anyone who's taking care of the live stream, let's end it. Bye bye, guys. I hope you had a great time. Hope I was able to add some value to your lives. Thanks a lot for watching. Bye bye. Stop sharing and stop the stream.